what is the concept we are going to be discussed here means today's class we are going to discuss about the bubble sort means what are the different types of sorting algorithms are there. Sorting nothing but what, arranging the elements in ascending order. Okay, less smaller number to the bigger number means we are going to be called it as what, ascending order, or bigger number to the smaller number. Arranging the elements in a sorted manner, we are going to be called it as what, sorting. And inside the sorting, what are the different types of techniques we are going to have? We are going to have many techniques, but in our syllabus we are having only 3 algorithms called. What are the algorithms we are having here means in our syllabus we are having bubble sort, we are having insertion sort, and we are having selection sort. What are the 3 algorithms we are having here means bubble sort, insertion sort, and what is the last one we are having here means selection sort here. And today's class we are going to discuss about these 3 algorithms. And in the last class we have discussed about the what is meant by the linear search and what is meant by the binary search. And linear search means the element is going to be, how the element is going to be compared here means all of you just in the last class also we have seen this animation. And okay, once again we are going to see about the linear search and binary search within a quick time. And here suppose if I am searching for an element called 994, if I am searching for an element called 994 here I am typing something as 994, and here I am clicking the linear search. And here the first 994 has been compared with the 0 index position 9, after that 26, after that 36. Like this it is going to be compared with all the elements. It is going to compare with all the elements. Here how many comparisons are going to be done inside the linear search here means inside the linear search it is going to be compared n number of comparisons if the element if the given searching element is existed at the last searching element is existed at last position. If we are searching for the 994 means 994 is existed as which element, 994 is stored at which position here means 31st index position. Though so how many comparisons are going to be done here means n number of comparisons are going to be done here. How many comparisons are going to be done, how many number of comparisons are going on here means how many comparisons are going on here means n comparisons are going on here. And here finally the element has been searched here and the element has been matched here, so it is showing it as what, element found. And this type of searching technique we are going to be called it as what, linear search. Suppose if I whatever the element here I am searching for the element called 9. 9 means how many comparisons it is going to be done, it is going to do only one comparison. And the element has been found at what, 0 index position. That's why it is showing something as what, it is showing the element has been found at a 0 index position. And here what is the best case means if the element, whatever the searching element is there, that searching element is existed at first position means it is going to find out in a quick time. If the element is existed at last position, or if the element is not at all existed inside the given list means it is going to take the huge number of comparisons compared to the what, binary search. And here what is the inside the last class we have been discussed about the program, and all of you know well known about the arrays. And here we are storing all the elements inside the array called array. Inside this array we are storing all the elements. And here we are taking the input from the user as what, the searching element we are storing inside the what, key num. And inside the if we want to search this element here means inside the for loop we are writing one condition as what, key num double equal to array of. And it is going to start the comparison from the where 0 index to the what, num index. If the element has been found means found is equal to 1, and what is the statement it is executing? Break. And if the element has not been found means it is going to compare n elements. It is going to compare key num with the what? N number of uh, n number of elements. And this is the thing about all about what? Binary linear search here. And in the last class, what is the one more concept we have been discussed here means what is meant by the binary search here? What is meant by the binary search? And whenever we are discussing about the binary search means what are the things we need to be remember for all the time means we need to remember something as three variables as what? Low variable, mid variable, high variable. And here what is the inside the binary search? We are dividing the list into the what? Sub list. We are dividing the list into the what? Some parts. And how we are going to be divided, and how the element is going to be searched inside the binary search, and how many comparisons are going to be done using the what? How many number of comparisons are going to be done by using the what? Binary search. We are going to be discussed. In the last class itself we have been discussed, but one more time we are going to see the animation, and how the comparison is going to be done here. How the comparison is going to be done inside the program here. To find out the mid value means what is the thing we are indicating? Low place high by 2. This is the logic we are using. By using this logic only, we are dividing the array into the what? Partitions. We are dividing the array into the what? Partitions, and we are making the something as what? Comparisons. And within the compared to the linear search, we are making some less comparisons and find outing whether the element is existed or not existed. We are find outing whether the element is existed in the given list or not. We are going to be find outed here. And all of you see carefully see this animation here. Suppose if I am find outing for the something as what? Here I am find outing an element called 225. Here I want to find out the element called 225 by using the which type of searching technique here means binary search. By using a technique called binary search. And here I have clicked. Here what are the three variables it is considering? Low value, mid value, high value. Now the low value is what? 0, and the mid value is what? 7, and high value is what? 14. These are nothing but the index position values. And again it is comparing 225 has been matched with the okay, whether it is greater than 452 or not. If it is greater than means it is going to search inside the second partition, otherwise it is going to search inside the first partition. Again the first partition is going to be divided it into two partitions. And again it is okay, 14 means what is the 7 up to here one partition, and up to here one partition, and remaining partition is from 7th index to 404 14th index position. And here whatever the element 225 is greater than 204 or not. And if it is greater means what is the thing it is going to be done? It is going to compare. Here all of you see carefully here. And if I am clicking on the binary search means first low, high, and this color is indicating mid. And after that the value is less than 452, so it is again it is dividing it into the partitions. Again it is dividing it into the what? Once again it has been divided it into the partition, and the value is less than this value, and it is checking. And now what is the again the value has been founded at where 225 here. And how many times the red color box is going to be highlighted? That red color box is highlighted box, we are going to be called it as what? Comparisons. And how many times it is going to be compared? All of you check once here. For one comparison, and two comparisons, and three comparisons it has been done. And four comparison, and at the fifth comparison it is going to find out the element. At fifth comparison it is find out in the element. At fifth comparison it is going to find out the element. Suppose if you applied this 225 for the linear search means how many comparisons it is going to done? 1, 2, from 0 index to the what? 8 index. And okay, it is going to compare one comparison inside the linear search, 2 and 3 and 4 and 5 and 6 and 7 and 8 and then nine comparisons it is doing. And by seeing this, what is the thing you are understanding which one is efficient means? What is the thing we are going to be said? We are going to say it as what? Binary search. We are going to be called it as what? Binary search. And even though if you are using some 994 means, how many comparisons are going to be done inside the linear search means 30 comparisons it is going to be done. But whereas inside the binary search it is going to do some less comparisons than the linear search. So the which type of searching technique is preferable here means binary search is preferable. But inside the binary search, what is the important point to be remembered here means we need to arrange the elements in which order here means ascending order, some lower to higher, or we need to arrange the numbers in descending order. In an assorted manner we need to be stored. If you are storing the elements in an assorted manner only, then only we are going to be find out the element with element inside the binary search inside the binary search within a quick time. And all of you here, if I am executing this binary search program here I am executing this binary search program. And here what is the thing we are giving? And all of you listen carefully here. uh, Here I am executing. And here number of elements means here I have given some 5. And here I am not giving in the sorted order. Here I am giving something as 5 and something as 2 and here 8, 1 and 0. And here first the elements has been arranged in which order? The elements are arranged in which order? Sorted order. The elements are arranged in the sorted order is what? 0, 1, 2, 5, 8. And after that we are find out in the element. After that, if I want to what element I want to be searched here, and I want to search it as what? 5. And here the 5 has been find out and search successfully. And inside the binary search, what is the important thing to be noted here means first of all we need to arrange the elements in which order? We need to arrange the elements in a sorted order. And inside the binary search, what is the 3 variables we need to be important variables we need to be declared here means low, mid, high. We need to declare some 3 variables as low, mid, high. And here what is the to find out the mid value means what is the logic we need to be written every time here means mid is equal to what is the logic we need to be written? Mid is equal to low plus high by 2. We need to be remember. And again here what is the which type of scenario we are applying here means we are applying a scenario called divide and conquer approach. We are applying here, we are applying something as what? Divide and conquer. Divide and conquer nothing but what? The big problem has been divided into the what? Smaller tasks. And here the n elements partition has been divided it into the what? N by 2. N by 2 has been divided it into the what? N by 2 by n by 2 whole divided by 2. Like that we are going to be divided. This is all about what? Binary search. And now we are going to see something about the what? Sorting techniques. And what are the different 3 different types of sorting techniques we are having? What are the 3 different types of sorting techniques we are having? All of you listen carefully here. And now what is the concept we are going to be discussed here means bubble sort means what? Insertion sort means what? Selection sort means what? These are the 3 algorithms we are going to be discussed now here. And all of you listen carefully here. And here what is meant by the bubble sort we are going to be seen here. And here what is meant by the bubble sort here means all of you listen carefully here. And here we are having some elements as what, here I am having some element as 10, and here I am having some element as what, 5, and here I am having some element as 6, and here I am having element as what, 7. And it has been stored at which index position here means 0 index position. It has been stored at which index position here means 1 index position, and 2 index position, and 3 index position. And suppose this is an array, this is an array, and it has been stored in these index positions. And inside the bubble sort, which type of comparison it is going to be done? Here 10 is going to be compared with the what, 5. So what is the first comparison? 5 is going to be shifted here, and 10 is going to be done here, and 10 6 7. And after that, what is the, again the comparison is going to be done. Then what is the thing it is going to be done here? 5, and in the next iteration this 10 is going to be compared with the 6, and 6 10, and what is the thing it is going to be done? 7. And after that, what is the comparison it is going to be done? 10 is going to be compared with the 7, and it is going to be 5 6, and 7, and 10. And after that, what is the, still it is going to, even though we have already find out the result, but it is going to do some comparisons as what, again it is going to check. 6 is going to be compared with 7, 6 is less, so whatever the position is there, there itself it is going to exist. Again next, what is the here as it is, we are going to indicate 5 6 7 10. And again we are, 7 is going to be compared, again the values are being as it is, and again like this, this sorting is going to be done. And here what is the thing it is going to be? Here first of all, it has been compared these two elements, and next it has been compared these two elements, next it has been compared with these two elements, after that again it is going to compare these two elements. Like this it is going to do the comparisons. And here all of you, by seeing the animation of the bubble sort, you are going to understand easily here. And all of you listen carefully here. Inside this bubble sort means what? Compare. Here all of you see carefully here. Compare a pair of adjacent terms. Here what is the, for 10 adjacent value is what? 14. For 14 adjacent value is what? 14 comma 10. And for this 14, what are the adjacent values we are having? And 29, and okay, 14 before value is what? 14 itself, and 29 adjacent value is what? 37. And okay, what is the step 1? Compare a pair of adjacent items A comma B. Compare a pair of adjacent items A comma B. And after that, what is the thing? If they swap the pairs, items are out of order. In case when A is greater than B, A is greater than B. Suppose here the value, suppose if the value is, here the value is greater and here the value is lesser, means what? Here 14 is existed, 10 is, here it is existed. If in this manner the values are existed, means we need to interchange. What is the technique we need to be applied here? Means we need to apply something as what? Swap that pairs. We need to swap that pairs. How many number of, repeat the step 1 and step 2 until we reach the end of the array. What is the step 1 and step 2 is going to be repeated until we have ended, we have reached to the last end position of the array. And after reaching the end position, automatically the elements are going to be stored in which order? Here means sorted order. Now we are going to see practically, now we are going to see animation based practical. And here I am clicking on the what? Bubble sort. And here what is the 29, 10, 14, 37. And here what is the, all of you listen carefully here. And okay, here once again I am clicking, and first of all this 29 is compared with the what? 10. And after that, okay, it is going to be compared with the what? All of you watch carefully here, and if you watch carefully means you are going to understood the logic. 2910. Here I'm clicking create, and here I'm keeping it slow, and okay, sort, and here I'm clicking on the go, and bubble sort. Okay, and first of all 3 is compared with the what? 44. After that 3 is compared with the 44 is compared with the what? 38. And after that what is the like this, 47 is compared with 36, and 47 is compared with 26, and 47 is compared with 27, and 47 is compared with the what? 2, and 46 is compared with the what? 7, and 47 is compared with 19, 47 is compared with what? 50, and 50 is compared with the what? Okay, and after that it is going to be started from where? Now 38, like this it is going to do the comparison. Suppose if you take less number of comparisons, create, and here I am taking only less values, and go, and sort, and okay, and here what is the sorting technique it is going to be? 29 10, and 29 is compared with 14, and 29 is compared with 37, and if less means no comparison, and 37 has moved here again, 10 14, like this, 29, and next 29 37, and even though it has been arranged again, once again it is doing until it is reached to the what? End value. Until it has been reached to the what? End value, it is going to be sorted. And this type of sorting we are going to be called it as what? This type of sorting technique we are going to be called it as what? Bubble sort. We are going to be called it as what? Bubble sort. And which type of sorting we are going to be called it as a what? Explain. Okay, which type of sorting we are going to be called it as what? Selection sort here, or insert. Selection sort means what? All of you listen carefully here, and inside the selection sort it is going to select the minimum element. It is going to select the inside this n array, what is the which element is less, that element is going to be selected, and that element is moved to the what? First position here. And all of you here selection sort, and here I'm clicking on the selection sort, and 29 10 is minimum. So, and again this 10 is minimum, so it is the 10 has been moved to the which position? First position. Again it is going to find out from here to here, it is going to find out the minimum element, which element is minimum. And here inside this 29 14 37 13, what is the minimum element? 13. So it has been moved to the what? Second position. It has been moved to the what? Second position. And next inside this, what is the minimum element? 14. Okay, 29 is minimum element, it is going to move to the what? Here. And last minimum element is what? 37. And here inside the selection sort, what is the first step we are having? Finding the position x of the what? Smallest item. Finding the position x of smallest item in the range, and L to n minus 1. L to L index position to the what? N minus 1, and swap the x item with the what? Lth item. Swap the x item with the what? L item, and increase the what is the thing is going to be increased? Lower bound L by what? 1. And while doing the first swapping here means, while doing the first swapping, what is the how many elements are going to be considered? 5 elements are going to be considered. After for doing the second swap means how many comparisons are going to be done, how many elements are being considered, only 4 elements. And after doing the second swap, how many elements are going to be considered inside this list means 3 elements are going to be considered. And after doing find out in the third swap, how many swappings are going to be done here means only one swap it is swap. And after this there is no swap needed, only single element. That's why we are going to store the element in the last position here. And here once again, if you see this selection sort means, first of all it is find outing the minimum element. And inside this list minimum element is what, 10. And it is selecting that 10. After selecting the 10 is going to be compared with the remaining elements. And if the value is less means it is moving to the what, first position. Again it is find out in the minimum element. Here the minimum element is what, first of all 14. After that what is the minimum element, 13. That 13 has been moved to the what, second position. And here again it is find out in the minimum element 14. 14 itself is the minimum element compared to the what, 37 and 29. So it has been kept there itself. And 37 and 29, what is the minimum element, 29. So it has been moved to the what, okay, here. And the last element. And like this selection sort is going to be done. It is selecting what is the important point to be noted in our mind here means, it is going to find out the first smallest element inside the what, given list. And that smallest element is going to be moved to the what, first position. And it has been kept separately. And whenever we are doing the sorting for next time means, we are not going to consider this first element, we are going to consider the other than this first element. And after find outing the next sort minimum value, what are the elements are going to be considered here means, last 3 elements are going to be considered. Okay, such type of thing we are calling it as what, selection sort. Inside the selection sort, what is the first thing we need to be remember, smallest item. And what is the technique we are going to use for interchanging here means, swap technique we are going to be used. And what is the thing to increase the bound value for every iteration means, what is the thing, increase the lower bound by what, L by what, 1. And this type of sorting we are going to be called it as what, selection sort. And the last sorting technique we are going to be discussed it as what, insertion sort. What is the which type of thing we are going to be called it as what, insertion sort. Here we are having chords, playing chords in this manner. And start with the what, first chord, one chord in hand. And pick the next chord and insert the proper sorted order. And first chord is what, here 40. And 40 is compared with the what, 13. And 40 is greater than 13. That's why 13 is going to be inserted first, and 40 is going to be kept as what, second. And okay. And next, what is the chord we are having inside in our hand here means, 40. That 40 is going to be compared with the what, 20 and 8. 20 is what, less. So we are going to take the which chord, 20 chord. And 40 is going to be, okay, like that we are going to be done. All of you see this animation here. First of all, what is the thing, start with what, start with one chord in hand and pick the next chord and insert it into the what, proper sorted order. Pick the next chord and insert it into the what, proper sorted order. And repeat the previous steps for all chords. And here if I am clicking on the insertion sort means, what is the thing it is going to be, first of all it is find outing something as what, minimum. Okay, here 13 is less. And picked chord is what, 13. And it has been, now next picked chord is what, 20. And 20 is compared with 13 and 40. And it has been inserted here. And next picked chord is what, 8. And 8 is going to be inserted where, and here it is going to be inserted. And which one is efficient here means, comparing the 3 sorting techniques here means, bubble sort, selection sort, and insertion sort means, which one is efficient means, insertion sort is efficient than what, bubble sort and selection sorts here. Okay,